Welcome to Aerial Robotics, the first course in the robotics specialization. This course exposes you to the mechanics, design, the control, and planning of robotic flight in three-dimensional environments for micro-aerial vehicles, with an emphasis on quadrotors, a special but important class of micro-aerial vehicles. You will learn about the opportunities in the field of aerial robotics, or drones. You will get a basic understanding of the dynamics of micro-aerial vehicles and how to control them. We will discuss the challenges in developing sensors for safe and autonomous flight. You will learn how to get robots to plan and execute complex maneuvers in three-dimensional environments. We will discuss the effects of size on maneuverability and agility. We use a combination of simple models, interactive simulations, and illustrative experiments to give you an understanding of how robotics technology is changing the world we live in. And now, let's begin. Unmanned aerial vehicles are closely related to aerial robots. Over the last 30 years, the number of UAVs in the world have grown exponentially. In 2010, there were predictions of a $10 billion industry, with most of the applications being in the military sector, the civilian sector, and of course, the DIY sector, where there are thousands, if not millions of users developing all kinds of software and hardware platforms for UAVs. The FAA that year predicted over 15,000 civilian drones by 2020. Let's fast forward to today. It's now clear that this industry is even bigger. There's widespread interest in UAVs. In fact, there were 15,000 drones sold in the US alone every month. It's already a $15 billion industry projected to grow to $25 billion in 2020. And the applications range from agriculture, photography, inspection, construction, border patrols, and producing movies. There are many other terms that we use to reference aerial robots or unmanned aerial vehicles. The military uses remotely piloted vehicles as a descriptor for vehicles that are unmanned. And of course, the layperson and the press know them as drones. The military would question the use of the term drones. General Norton Schwartz, the person who actually used drones and actually popularized the use of drones within the military, is said to have said that drones mischaracterize what these things are. They're not dumb, nor are they actually unmanned. They're remotely piloted vehicles. And you can see that in this picture. There are two UAV operators operating a vehicle from an Air Force base in New Mexico. And this is true for every remotely piloted vehicle that the military uses. But we're not going to draw the distinction. For us, UAVs are the same as remotely piloted vehicles, and that's the same as aerial robots, and that's the same as drones. This field is rapidly growing. In fact, it's evolving, and we're just in the beginning of this evolution process. There's also a lot of concern about regulation. People are worried about UAVs, whether they're safe or not. People are worried about privacy. These UAVs usually have cameras, and the cameras take pictures that can be intrusive. There's also a question of security as adversaries think about how they can manipulate sensors or control systems and tap into the inner workings of a UAV to do things they were not designed to do. Our interest in this course is primarily in micro-aerial vehicles. In contrast to the vehicles that you see on the right-hand side of the screen, which can weigh a lot, which are very big and fly high above the Earth's surface, the ones on the left-hand side of the screen are much smaller. They're capable of navigating in indoor environments and three-dimensional unstructured settings. And that's what we're going to focus on here. There are many different geometries, many different designs you can choose to build microaerial vehicles. You might consider using fixed-wing vehicles. These have a disadvantage as you think of them as operating in confined spaces. Vehicles like this cannot just come to a stop in midair. They cannot hover like helicopters can. Flapping wing vehicles that are patterned after insects or birds can in fact stop and hover. If you look at the hummingbird, it's capable of hovering in place by just flapping its wings. And people have tried to build vehicles based on these kinds of geometries. However, the fluid mechanics is complicated. It involves studying vortex shedding from wings and unsteady flows, and it's very hard to model these and invert these models to control these kinds of vehicles autonomously. The obvious geometry to consider when you consider microaerial vehicles are rotorcrafts. And there are many different types of rotorcrafts you might imagine. Helicopters are the ones that we're most accustomed to seeing. Rotorcrafts, which consist of two coaxial rotors spinning in opposite directions, are also a candidate geometry. But the simplest geometry are multi-rotor aircrafts, quad rotors, or hex rotors, as you see over here. This has 6 rotors, all controlled independently, that allow the vehicle to be controlled in height and in orientation and in translation. The vehicle of choice in this course is going to be a quadrotor. Again, this vehicle has 4 rotors powered by independent motors, all mounted on a fixed frame. And we try to make these vehicles smaller because by making them smaller, you also make them safer and you make them more maneuverable.